Hey y'all, welcome back to Math Rescue. I'm Andre and I make content to take away the stress of learning math. In this video, we're going to solve a cubic without graphing. That means using the rational root theorem to find possible roots, then evaluating so we can break the polynomial apart quickly. Once we find the first root, the rest of it is cake. Let's talk about it. We have the polynomial x to the third plus x minus 10. First thing we're going to look at is we're going to give it some consideration to think about what we might expect to happen. The fundamental theorem of algebra tells us that we're going to end up with three roots, whether they're complex or real. We're going to end up with three in total. From here, let's go ahead and use the rational roots theorem, sometimes also referred to as a rational zeros theorem, to figure out what my possible roots could be. To do the theorem, we take the coefficient of the leading term and we look at the constant. We list out their factors. Factors of 10 are 1, 2, 5, and 10. The factors of 1, just 1. And then we set them up in all possible combinations as P over Q. In this case, we're not going to end up with a lot of combinations because the 1 really simplifies things. So we end up with, so I'm setting up P over Q. We end up with 1 over 1, 2 over 1, 5 over 1, and 10 over 1. So those are all my possible roots here. I also want to make sure to account for the positive and negative case. Now, I don't really need to say that these are over 1. It's kind of redundant. Anything divided by 1 is just itself. So I'm going to go ahead and remove the fact that it's... Alright. From here, what I've done is I've created a table so that I can kind of quickly evaluate these, and I want to see which of these is actually a 0. Which of these, when I plug into the polynomial, actually gives me a 0 out. So the way I did this was I set this up in my Descartes scientific calculator. I was able to go through this pretty quick using Desmos. What I did is I made this first line. I just left empty parentheses where the input's gonna go. And then from there, I went ahead and started plugging in the different x values. And that helped me to really do this quickly. This could be really time consuming. So using my Desmos calculator, let me go ahead and record the values I found. So negative 1000, negative 140, 20, 12,000. Zero. Here's a root that actually worked, and negative. Right here, I found one that actually worked. So x equals 2 works. So then what I'm going to do from here is I can actually use that x equals 2 to break down the cubic. So what I would do is I would take x to the third plus x minus 10, and I'm going to divide it by x minus 2, which I just found in that step 2 there. When I do that, that'll turn my cubic into a degree 2, so a quadratic. I end up getting x squared plus 2x plus 5. And from here, what I'm going to do is I'm going to take this quadratic and I'm going to pop it into the quadratic formula. Now, when it enters the quadratic formula, I'm going to get two imaginary solutions. I'm going to get that x equals -1 minus 2y, and I'm also going to get -1 plus 2y. So altogether, that gives me my full picture of the polynomial. Let's talk about how to sketch the graph here. So it says the function has one real zero at x equals 2. So the function goes through 0, 2. That ends up being an x-intercept. And it doesn't cross the x-axis anywhere else. That's my only real root. That's my only... because the degree is odd and the leading coefficient is positive, we can make some determinations about our end behavior. You can use an end behavior chart to figure that out. So on the left side, the function is going to be... So the function is going to look something like this because of the end behavior chart. So on my left side, we're going to be going down. And on my right side, we're going to... From here, you could use this information to create a rough sketch of the polynomial. I'm Andre with Math Rescue. If you found this video helpful, please like and subscribe to support the channel. I post videos regularly. My goal is to make you feel super confident in math. See you in the next one.